Right now, thousands of APIs are running in the background. Your phone checking messages, the weather widget updating, Spotify loading your playlist. But not all APIs are created equal. Some are built for speed, some prioritize security, others handle real-time communication. Pick the wrong one, you're going to have a bad time. So today, we are breaking down 7 API types that power everything from banking apps to Netflix to Fortnite. And I'll show you exactly when to use each one. Let's dive in. Let's start with REST, the one you have definitely heard of. REST stands for Representational State Transfer. It's just a pattern for how computers talk over the internet using HTTP methods. So when you open a video on my channel ByteMonk, your app needs to fetch data. It sends a GET request, and you get back JSON with everything about that video. That's a GET request, fetching data. Now when you hit that like button, your app sends a POST request. The server creates a new like record and updates the count. That's POST, creating something new. There is also PUT for updating data, like editing your comment, and delete for removing data, like unsubscribing from my channel. Please don't do that. But here is what makes REST powerful. It's stateless. The server doesn't remember you. Every request is independent. This means you can add more servers and scale horizontally. That's why REST powers most of the internet. If you are building standard CRUD applications, create, read, update, delete, REST is perfect. Mobile apps that need to talk to backend servers, REST. You are building a public API that other developers will use, REST is the standard they expect. Basically, anytime you need something simple, reliable, and universally understood, REST is your answer. Honestly, REST is your go-to for about 90% of API scenarios. It just works. Now, if REST is a casual phone call, SOAP is your formal business contract. SOAP stands for Simple Object Access Protocol. Despite the name, it's anything but simple. Every SOAP message is wrapped in XML with strict structure, an envelope, a header, and a body. Now you are thinking, this looks ancient. Why even use this? Because SOAP has built-in enterprise-grade security and reliability that REST doesn't. When you transfer money between banks, that's probably SOAP. Healthcare systems exchanging patient records? SOAP. Government systems? SOAP. It's heavy, verbose, not sexy. But when you absolutely need guaranteed delivery and paper trail for compliance, SOAP is your answer. Now let's talk about speed. gRPC is Google's answer to what if we made APIs really fast? REST sends data as text in JSON. Easy to read, but inefficient. gRPC uses protocol buffers, a binary format that's up to 10 times smaller and faster. Plus, gRPC uses HTTP2, sending multiple requests over a single connection simultaneously. And gRPC supports 4 communication patterns: simple request response, server streaming with continuous updates, client streaming with continuous data upload, and bidirectional streaming, where both sides talk simultaneously. Think over your driver's real-time location, server streaming, your GPS as you move, client streaming, chat messages, bidirectional streaming. Netflix uses gRPC internally, so do high-frequency trading platforms. So when do you use gRPC? Basically, in case of microservices communication, real-time streaming, or when your performance is critical. GraphQL is a completely different way of thinking about APIs. Here is the problem it solves. With REST, you either get too much data, overfetching, or need multiple API calls, which is underfetching. GraphQL flips this. You decide exactly what you want in a single query. One request, one endpoint, exactly the data you need. The real magic? GraphQL APIs are self-documenting through schemas. So front-end developers know exactly what they can query without asking the backend team. GitHub's entire public API runs on GraphQL. So does Shopify. Netflix runs 70 plus federated GraphQL services handling billions of requests daily. Now, for a completely different approach, Webhooks. With normal APIs, your app constantly checks for updates, like walk into your mailbox every 30 seconds. That's polling, inefficient. Webhooks flip this. Instead of you asking, the API calls you. It's like a doorbell. The mailman rings when a letter arrives. Here is how it works. You give the API service your callback URL. When something happens, the service sends a POST request to your URL. Your app receives it and reacts. That's why they are called Reverse APIs. Stripe fires webhooks when payments succeed. GitHub triggers them on code pushes. Shopify sends them when orders are placed. Webhooks are mainly used during automating workflows, instant event notifications, or syncing systems in real time. WebSockets are like opening a permanent phone line between your app and server. Normal HTTP, you call, get an answer, hang up. Want to talk again? You have to call back. WebSockets keep the line open. Once connected, both sides can talk anytime instantly. Perfect for chat apps, live sports scores, stock trading, and multiplayer games. Unlike REST, where clients always initiate, WebSockets let servers push data the moment something happens. Alright, last one. And this one is genuinely wild. WebRTC. It stands for Web Real-Time Communication. And it's not just an API. It's a complete framework that lets browsers or mobile apps talk directly to each other. No server in the middle. Think about that for a second. When you are on a Zoom call, your video isn't going to Zoom server and then to the other person. It's going straight from your device to theirs. Direct peer-to-peer. Now here's the thing. This sounds simple, but it's actually solving an incredibly hard problem. Your laptop is behind your home router, your friend is behind their router, and there are firewalls, NATs, different network configurations. How do two devices that don't know each other's real IP addresses connect directly? This is where WebRTC uses something called signaling, a clever three-step process involving stun servers and fallback mechanisms to establish that direct connection. It's pretty fascinating how it navigates through firewalls and NAT to make this work, but that's a deep dive for another video. Once connected, WebRTC handles everything automatically. Adaptive bitrate streaming, codec negotiation, jitter buffering, all in real time with latency under 500 milliseconds. So, where do you see WebRTC in action? Well, every time you jump on a Zoom call or a Google Meet, or you are chatting on Discord, that's WebRTC working behind the scenes. Real-time multiplayer games where a single frame of lag can cost you the match? WebRTC. Those browser-to-browser file sharing services where you can send a file directly without uploading to its server first? That's WebRTC too. Even live streaming platforms like Twitch are using WebRTC to cut down latency between streamers and viewers. And here's the best part. It's built into every modern browser. You don't need to install plugins, you don't need special software, it just works right out of the box. Now, I have done deep dives on REST, GraphQL, gRPC, all the other APIs we have covered today. But I haven't done one on WebRTC yet. The signaling process, stun and turn servers, how to actually build a video chat app from scratch. There is so much to unpack here. So let me know in the comments if I should do a deep dive on WebRTC and actually build a video chat app from scratch. And if this was valuable, hit subscribe. I break down tech like this every week. Thanks for watching.